Welcome to this video from the RC Ground School. In the earlier videos on the topic of choosing a transmitter, I've referred to a couple of terms that we'll look at a little more closely here. They are channels, memories, and telemetry. Transmitter channels are the number of model functions a transmitter can control. There are some advanced digital techniques that vary from this definition, but in normal operations, one channel can control one function. For example, a 4-channel transmitter can control throttle, ailerons, elevator, and rudder. 4-channel radios used to be considered the minimum number of channels you'd want to consider. More recently, that's changed. A 6-channel radio controls the same functions as the 4-channel transmitter, plus gear and flaps, or perhaps an onboard stabilizer. With the cost of transmitters coming down, 6-channel transmitters are now considered the minimum. For larger aerobatic planes with separate servos connected to both left and right controls, more channels allow the pilot to make very fine adjustments to each flight control while using what is called mixes to coordinate their movements. More channels also allow for channel controlling glider tow lines, bomb or parachute drops, or other actions. When the price difference is small, choose an 8 or 9 channel transmitter if you can afford it. You'll grow into it fairly quickly. Transmitters and receivers have to have at least the number of channels necessary to operate your model. To operate a basic 4-channel model, you'll need 4 transmitter and 4 receiver channels. That doesn't mean you can't have extra unused channels. In other words, it's perfectly fine to use a 6-channel transmitter and a receiver with a 4-channel model. As you might expect, different manufacturers use different channel numbers to control different functions. Be sure to read your transmitter's manual to see what channel number controls what function. Other manufacturers solve this problem by labeling their receivers with the function instead of a number. This makes it easy to match the function to the channel. Most of these manufacturers label channels for throttle, ailerons, rudder, elevator, and landing gear, and then refer to additional channels as aux1 and aux2, and so on. Now, let's move on to the concept of memories. When you get to be my age, the old joke is that memory is the second thing to go, and I've forgotten what was first. Well, your computer radio's memories are designed to keep you from having to remember the various settings required by your model. Most transmitters will allow you to program dozens of models, each into its own separate memory. That way, when you go out to fly, you simply double-check that the transmitter's memory name matches the model you have with you, and you're good to go. The Spectrum brand even has a data variable that, once bound to a specific model's receiver, won't allow you to mistakenly try to fly the model with the wrong memory selected. Here are just a couple of variables you'll be able to set via transmitter memories. First, you'll be able to give your model a name. This makes it easy to match your memory to your model. Next, you'll tell the transmitter whether the model is an airplane, a helicopter, drone, and so on. Then, you'll tell the transmitter what type of wing your airplane has. Does it have 1 or 2 aileron servos? Does it have flaps? If so, how many servos control them? You'll also set the direction the servos move and to what degree. Most servos can be set to move from 0 to 125%. You'll also set up the transmitter's flap system if your model has flaps. I hope you can see that you just can't fly a very complicated model with a basic radio. Again, this isn't a comprehensive list, but I hope you get the idea. If you'd like to see more on this topic, I'll link to a video I've done on programming the Gavin 6C transmitter on this video's end card. Whether you use the 6C or not, it will give you a good overview of computer radio programming. Last, let's look at what's known as telemetry. Telemetry refers to information coming from the model that indicates various components' status. For example, several Tier 1 and Tier 2 transmitters will receive telemetry information from receivers that are designed to transmit it. Common information includes the battery voltage, battery temperature, engine performance, and so forth. If your model has a GPS receiver, you can also get real-time information and alerts when the model goes beyond the limit you program into the transmitter. For example, you can program the radio to tell you when the model has exceeded a specific altitude or alert you when it has flown further away than the programmed distance. Some telemetry systems may require additional sensors to report the full range of performance information. Except for altitude, distance, and battery alerts, most telemetry data will be used after the flight to fine-tune your model's performance. In our next topic, we're going to discuss various package combinations manufacturers use to meet different modelers' needs. Their marketing people know the importance of capturing a customer for follow-on purchases. These model packages will also play a role in deciding on what brand transmitters you choose, so keep watching. As we close this video out, if you found it helpful, please click on the thumbs up icon and subscribe to the RCPlaneviews.com channel. Click the bell icon to be notified when I post new videos. Thanks for watching.